Here, multiply 2. So a half and half, so finally it's 1. 2 multiply u. 2 multiply 1 minus u. So finally, it's still 1. Because of a relative value. Probability half, probability half. Right? All right, so you can check the other details. And right now, we have the new example. And new example says, okay, if we have the line here, but we have something like, we have the area here. It should be the trapezoidal, right? Trapezoidal shape. The shape should be trapezoidal, but how to have the parts to have the contribution. Previously, we have the separated part to have the contribution. But right now, is it possible to have the contribution? Before we have the composition, at least the line here, so that you have a line, it should be no problem. Line there, we should have a CDF, no problem. And so that solve it, we should have the solution. It should be no problem. But rule of one invalid solution. So this one, I think it's okay for the transform. However, here, from the previous one, why is this one plus the second one? Because we pass on this. All right, we have a line here, and we have a horizontal line here. So we form the two components for the same interval. First one based on this, and second one based on the line, and put them together. Even we have the same range. The range here is 0 to 1. All right, so if we have the 1 here, the height should be A through normalization. Finally, it should be 1, is it okay? Because the area here is A. Through normalization, A over A is 1. And here, through normalization, even we don't have the normalization, finally, it should be, oh, okay, this one should be 0 to 1, 0 to 1. It should be 2. Even we don't care about the detail because the area here should be 1. Is it okay? So I use figure directly so that we have two components. One from uniform, one from triangular. Because of the current decomposition. I use decomposition. How I can have the decomposition? Previously, the decomposition left-hand side, right-hand side. Currently, the decomposition, the upper one and the lower one. That's all. And so that we can have the new decomposed factors of the individual index 1 and 2. If I use the figure directly, up to now, I use figure approach acceptable by you, Tobias. Acceptable? Okay, good. And Matt? Acceptable? And Sean? Okay. And here, Ken. And Jackie Fo. Why the two components? Acceptable? Okay, good. So, based on this one, I think likewise, this one you can solve it, and this one you can solve it, no problem. And so that we can have a composition algorithm. Likewise, to use, and so that this is the index lower than A because area is A. So lower than A, it should be index 1 here. Or otherwise, it should be index 2. So finally, the composition algorithm here is okay. So, summary, Summary about the algorithm is okay if given the result to have this. Yeah, and we did algorithm here, and Valentine algorithm here. Okay, and Sean and Ben. All right, that's all. As for the comparison, actually, some places should be corrected. The current table with some places to be corrected, but I skip it for you, and so that left to you to have the comparison. So we finish this one, but I should let you know the current example does not appear in the textbook. It's an actual exercise, the actual example. So this one is a special one. Well, this one, I just focus on the composition one, and I do not follow this one. No, I use figure to have the two components directly. So up to now, can you accept that one? It should be okay, right? If it should be okay, actually, how to decompose the twos actually still okay, but you should find, okay, rearrange, then you will have this. All right, so not really easy to have the decomposition from the equation. However, it will be easier to have the decomposition based on the figures. Is it okay? So that's why I prefer to let you know the approach using figures rather than to have the decomposition based on the equation. Finally, the equation will match our decomposition, but I start from the figure directly. About the two approaches, the first one should be intuitive. The second one, not intuitive, but finally serving as the way to validate. Is it okay? All right, so that's it about the current example. Is it okay? But even if you feel okay, take a picture for these first. Take a picture for these first. And then, based on your picture, to think about this. Then you have 2 minutes to finalize. And to wrap up, oh, okay, everything's okay for you, or something wrong for you. If something wrong for you, let me know. Well, we don't think so, and so that I can re-explain for you. If indeed you don't understand, do let me know, and so that I can re-explain something. If yes, okay, everything's okay, then no burden on you, and you understand, oh, and then it's easy for you. About the table, I skip it. In fact, something should be corrected, but I skip it. You can check it later. So let me make sure. Summary, okay. And if not okay, maybe you can add summary. And Enzo, same for members in good too. If anything wrong, you can discuss with Enzo. And Ulis, okay, Sam, Sean, you can discuss with Ulis. And Valentine, okay, and David, fine. So currently we have two cases. One, we should have the different range to have the decomposition. And the second one, we have the same range, but we can have the decomposition for the upper part and the lower part. And currently for the equation, in fact, you can pass on our figure to have the decomposition. And value, oh, okay, we can write in terms of the form. And so that we can meet the form of decomposition. But I skip valid the current formula so that you can validate for yourself. I skip it and go to the next one.